So to start things off, there is a Astrum video titled "This Bizarre Object, Light Years Away, is Bombarding the Earth with Antimatter." That's what its current title is. I don't know if that can change, but says it was released August 12th. And so I recommend you go and watch that video because that's what I watched and kind of got these, thoughts from while I was watching this. And it'll give you some more context and a better explanation of what it is I'm referring to and what I'm talking about. So I recommend you watch that. But it's up to you. You don't have to. Anyway, I think I want to go back and say that neutron stars or pulsars are neutrinos, or at least similar to neutrinos in behavior, with the direction of their emissions affecting how we see them and their seeming energy. The one pulsar that in the video is shown has high energy emissions, and the other one that's shown has low energy. One is pulsating basically like gamma rays at us or something along those lines, and the other one is only giving off radio waves. I might correct that later, but that's what I mean by high energy and low energy emissions. And so to me, this would probably be seen as high and low mass by us for neutrinos, even though we are not really changing, right? Even though they are not really changing. So what I'm saying is that, if you watch this video, it talks about how, looking at these pulsars in the distance, they look different, even though they are both pulsars. And it's just the orientation that they're facing makes them appear like they're only giving off different, like certain types of emissions, right? So when we look at a neutrino, we observe this mass oscillation, right? It appears like it is gaining and losing mass over time. And I think that this is because of the orientation of the neutrino as we observe it. Sometimes it's pointed, high energy towards us, and then sometimes it's low energy towards us, and then there's an in-between state where we get a little bit of both, and so it's this intermediate mass. To me, that seems, logical. And so, it also kind of ties in with the fact that I'm pretty sure that neutrino oscillations are periodic, and we kind of have an idea, we can calculate the rate that they change. So, that's kind of interesting, and I think that relates well to pulsars as well. But, that's another thing. So anyway, the low energy is the radio wave state, then the normal is in between, and then the high energy is the gamma wave state. So we also know that spinning objects in zero gravity have this weird periodic flip thing that they tend to do. You look up, what I put here is look up a video on it. There's a video that I watched where they spin like a washer or a nut, and it when they spin it off of the thread that it's on, it'll spin out straight, right? And it'll be moving out straight, but while it's moving this way, it's spinning. And then it does this weird thing, right, where it'll go whoop whoop, and then it'll turn around and then keep spinning, or it'll do this turn, right? Because it's stable, and then it kind of wobbles, and then it keeps turning again, and then it will flip back, right? So it'll flip back and forth. It's interesting. And so I think that because of that, that could be what causes this oscillation we observe, is this flip-flop back and forth of a spinning object, because we know that pulsars are spinning, right? And so this could be a part of why they go from pointing at us to pointing away, and we get this different observation. That may be why it oscillates back and forth over time. The trails off of the pulsars also make sense in my theory of as it's kind of like a bit of a wave forming, as like a sort of shock wave in front of the pulsar, and then this kind of void space behind it, as well as kind of a wave perturbating out as it flies through and makes space. So if you watch this video, which I recommend you watch the video, you'll kind of have a better understanding of what I mean. But this one image kind of looks like it's almost like a mushroom, right? Where it's got this big poof of a cloud that slowly comes back in, right? And so I think that that's interesting. The seeming mass and energy disparities also make sense, as something so small doesn't seem to have as much energy as a larger star, even though it does. So I don't know exactly the full context of that, because it's been a second since I watched the video, but I think that what I'm probably saying here is that it appears to have there's one that it gives off only radio waves, right? Or it's appearing to only give off radio waves, and one that's giving off gamma waves. So they appear to have different masses, and I think that this has to do with just how we observe them and the energy that they're giving off. And so their mass appears lower or higher depending on how, like, the orientation of it and which direction it's radiating in. And so there's another one that's what else I have here is the way that it is accelerating and emitting high energy particles also makes sense in my theory, as it travels through relatively empty space. So what I mean by this is these pulsars, as they're flying through seemingly a relatively empty space, are putting off these clouds of particulate and high energy particles in their wake, because they're moving so fast, right, that they're just kind of like leaving a trail, almost like a comet or something, or whatever. So I think that this makes sense with my theory as well, because they're moving so quick, they are just pooling up a big cloud of particles, and they're disrupting the mass around them, and kind of creating these points of higher density, and then they just kind of stay collected together because they have a lot of energy, and the energy is flying around all over the place. But as the energy dissipates, as things start to spread out more and more to dissipate this energy, then it no longer appears like a cloud anymore, because and we can no longer see it, because the energy has dissipated out and it's kind of spread out again. But it got all clumped together because of how quickly this pulsar is moving through. And so I don't know if I have a crazy amount to say with it. I think the main things I wanted to hit with this is that after looking at this behavior of pulsars and these findings these observations from two different types of pulsars that are seemingly very different, even though they're both the same thing, this leads me back to my mention of neutrinos being similar to pulsars, if not pulsars on a much, much smaller scale, and pulsars being neutrinos on a much, much larger scale. I think that is interesting, and I don't think I have too much more to say on it. I recommend you watch that video to kind of get some better context and maybe think about it for yourself a little bit, because at the end of the day, these videos are really not for telling you everything. It's for invoking the urge to think for yourself and, look into these things and see if what I'm saying makes any sense or if I'm just talking nonsense. And so I think I'll leave it there and say peace out.